Astro 30 here yet again, and I've got a couple of these subwoofer amplifiers to look at. There's actually two of them exhibiting similar problems. These are a Sonance Sub 10-150. They're Class AB design with linear power supply, which is nice. Now, the fault with these is there's little to no sound coming out of it, and as far as I know they power on, which is a good sign. I don't know if I'm going to need the control board connected to this, which has the two potentiometers and a switch on it to actually make this thing work to test it. But I've already noticed a couple of problems. Down here we've got a 220 microfarad 25 volt bipolar capacitor, and it's actually starting to bulge. And I believe this capacitor is part of the negative feedback and gain set circuitry of the input stage. So this goes to ground. One side is actually connected to ground, the lowest source of impedance. So I'm gathering that's what the job of this capacitor is. I'll show you on a drawing what I mean in a minute. And up here at the output stage, these solder joints are pretty terrible. When I tried to test this PNP transistor here, I was not getting a very good connection there, and it wasn't testing anything, so these joints are terrible. So the upshot of this is I'm going to have to pull this PCB out. There's a, I think this is a temperature coefficient PTC or NTC. This is just used to detect the heat of the heatsink and then shut the power amplifier down if it's overheating. This board's also got facility to add two extra output transistors and emitter degeneration resistors here to boost the current, so it'll be used in another model. The way this is designed is this is powered up the whole entire time the sub is plugged in and turned on. There's a relay here which would just disconnect the speakers when there's no input signal, but it doesn't turn the power amplifier off, or any of the circuitry off. So this will be powered on the whole entire time, which can lead to joints going dry and capacitors bulging like this. Now, why did the capacitor bulge? Well, it's a 25 volt capacitor. It may just simply be underrated for the job. Now, I haven't powered this up or even see what it actually does, but I'm going to do that now. It's connected to my dim bulb with safety. The main power switch is on. So if I turn the dim bulb on, well, it's currently in standby mode by the looks of things, and not much else happened. Don't know if I can get this to come in. Oh, as soon as I plugged it in, the light went green. That's interesting. I just can't hear that relay click. Doesn't appear to be anything there now. And it is green. Alright, I can't seem to get a voltage measurement across the flyback diode of the relay, so I'm going to have to take the board out anyway to fix the joints and change that capacitor. So I'll have a look on the underside of the board of how it's routed and then figure a way of testing it. I've got to deal with all this disgusting heatsink transfer compound that's gone all dry and crystalline. Okay, I've done some investigation, and this is how I think it's routed. We've got your output stage here. 47k feedback resistor goes directly into the 220 microfarad capacitor to ground, and then the other side this goes to a transistor. There doesn't appear to be any resistor between the capacitor and here. The underside of the board is just as bad with its solder joints as it is on top. So I've tested the relay on a power supply and it does click. I don't know if it's clicking in the unit, but what I'm going to do is I'm going to go through this PCB here, change that capacitor, resolder all the joints that are bad, and see what happens. I've just pulled the capacitor off, and they have actually on the footprint marked where the positive pin is, which is nice. Alright, I'm going to keep going. I had to buy a new roll of solder because the one Danish Dart sent me a couple of years ago has nearly run out. Now, this capacitor is slightly wider than the original one that was in there. So So it has to stand up a little bit higher off the board, but that's not really a great issue. There it is there installed, so it's slightly higher over the board than it should be, but it is what it is. Right, now I need to go around and resolder some joints and see if that makes a difference to this thing. I'm not holding out much hope at this point, but yeah, you never know. Okay, I've got it all roughly back together. Now, I've been doing some preliminary testing off camera and I'm not really getting an output signal. I found where the input comes in on this blue wire of the connector. The relay does engage once it's connected there, but not when it's connected directly to the input for whatever reason. Probably needs the control board connected to make it work. Not worried about that at this stage, but the signal's not passing through. So I turn it on, relay engages. Now I've got about 40 Hertz going in and nothing's happening. But if I touch one of these capacitors, it is doing something. This is the capacitor I'm touching. So I'm wondering if a component is open or it's another bad capacitor. So what I might try and do is touch the oscillator directly to that capacitor and see what the output does. Now I've got the scope on the lowest setting, and the survey says no. So let me up the sensitivity a bit. No. However, I can inject noise. Alright, I've got a speaker hooked up. It is passing a signal through there, but why is it not coming from the input connection through to here? That's the bit I'm a bit perplexed about. So I can't even pass the signal. So, Alright, I'm going to have to do some component testing, I think. Okay, I just took this 10 microfarad input capacitor off and I've tested it in circuit and I'm about to test it out of circuit. Positive there, negative there. Nothing's happening. It appears to be open. Okay, so I'll take a known good 10 microfarad capacitor here. If I can get it at least to stay on there. 9.7 microfarad. I believe that this capacitor, which I assume is the input one, is open. So I might change that capacitor out and see if it makes a difference. Right, I've been messing around. I believe this blue wire is actually a control wire. That's probably requires a DC voltage on there to turn the relay on off of the control board. I mean, I've got the signal going in there, but that's not where it goes. The red wire is actually the signal wire. But if I trick this into turning on and then touch the top of the 10 microfarad capacitor that I've just changed, albeit weak, there is a signal there. See that? Alright, with it hooked up to the speaker on the floor, I heard a pop come through the speaker. It is doing something. Alright, I tried hooking it up to the subwoofer and no joy, still not turning the relay on. Well, I removed the input board from the chassis and I've removed capacitor C16, I believe it is, which is a 2.2 microfarad 35 volt, I believe. Yeah, something like that. Yeah, 35 volt. It tests completely open. Yeah, cool. That capacitor is near where the LED, red and green LED is connected. I've gone around all the joints on all the connectors as well, just to make sure that they're soldered properly, but that capacitor is dead and I don't know if I've got another one. Well, I'm no closer to solving the issue with this. I replaced the 2.2 microfarad capacitor and it didn't do anything. However, through experimentation, I've disconnected that input board. I've joined the red and the blue wires together at the oscillator and provided a ground, and it's happily passing the signal. Isn't that, well, amazing? And it's putting out about 16 volts currently. Is that what it says? No, sorry, 6 volts. I amp it up and my dim bulb starts to get brighter. And it clips because, well, it's glowing really bright. So I find that odd and interesting at the same time. So I'm wondering if the audio signal has to be present on both the blue and the red wires in order for the relay to turn on and then pass an output. I now know I've got the amplifier working, so there's something up with this control board. I'm not 100% sure what it is, but when this connector is connected, the red wire gets held down by something. So the only other thing I can try is grabbing the second one of these subwoofer amplifiers and borrowing the input board to see if changing them over fixes the problem. Because if it fixes the problem, then there's something wrong with this board. Not 100% sure what, because, well, all the voltages are present at each of the op amps there. It's got plus minus 15 volt coming in, which would be coming off of well, ground, and these two extra wires on the connector here. So if I was to measure between here and say either of those pins, I should see a voltage. Right, as you can see, we've got negative 15 there. Well, we did have negative 15 there. And if I can get a good connection, so we've got positive 15 coming there on that pin and negative 15 on that pin. So I know that the voltages are going out to the board. Yeah, I'm at a loss as to what's happening here. I reckon there's something dead on this board, maybe an op amp. It's possible. I may not be able to fix it in this video. I might have to revisit this. However, what I'm going to do is I'm going to hook it up to a speaker now with a pot in line with the oscillator so it's not overdriving the amp. In fact, I might put the pot in now and see if it still functions. Okay, got a 100k linear pot there. I need a logarithmic, but it'll do for the test. At least I've figured out how the circuit's supposed to work. And we have no output. Right, well, I've got now about a volt. The relay dropped out. Relay's on, so I've got about 1.5 volts coming out of there, so that's probably going to be pretty loud. But let's find out by hooking it up directly to the speaker. Alright, so hooked up to the speaker. Is this a good idea? No, probably not. Well, I can hear it. It's a bit noisy. Let me just change the frequency. Okay, well, it is working as an amplifier. Very, very perplexing. Shut up. Thank you. So before I conclude this video, I want to deal with this mess of old heatsink compound, because at this point it's kind of doubtful that this board needs to come out again, so at the moment. So I'll clean all this up with some isopropyl alcohol and cotton buds and redo the compound. Crusty rubbish. I mean, it doesn't have to be super clean, but I want to try and get off as much of this junk as possible and reapply some new stuff. I may go through a bit of isopropyl alcohol. I'm actually using circuit board cleaner. It's the same stuff. But that's perfectly fine because I can always get more. I'm probably going to go through a lot of cotton buds too. Some of you may be asking a very important question. Astro, why are you actually fixing the heatsink compound? Look at that. Heatsink compound stuff up now when it's not actually completely working? Good question. Well, because the amplifier does actually work. It's just that the input circuitry to it doesn't. So, which I'll solve a little later. Now I'm going to continue cleaning, and I'll come back when I've got that done. Now, you don't need a lot of this stuff. I've got probably a little bit too much. And it's very watery too, but that will dry up over time. So I need one washer, like so. And I've lost the other one, there it is. Second washer. To apply a little to the device other than the VBE multiplier transistor here, because that doesn't have an isolator. It's already an insulated transistor, so there's no need to put extra compound on it. That should be more than adequate in position. Then I'll grab the screws that go through the transistors, through the micro washer, into the heatsink, just to line everything up but not tighten it up yet. Okay, can't forget this little thermistor thing. Okay, now the output stage. As soon as I tighten this down, see how that all just started to squeeze out. That's what we want. Finally, this one. Okay, that's done. And just to check that I haven't buggered anything, I've connected it back up the way I had in the last test. Still no close to solving this, but okay, we have nothing now. I know why, because it helps to actually plug the transformer in. That would generally help. Sweet. Well, I'm going to upload this video as it is, I think. Maybe somebody out there knows what could possibly be wrong with this PCB. I've tested transistors, they all test fine. So capacitors all test fine apart from the one I replaced. Then I tested it out of circuit on a different microfarad scale on the meter there, and it tested about 1.7 microfarad. It's a bit low, but okay. Okay, so this is the second subwoofer amplifier, and I really want to, conclude this video on a high. Now, the relay drive to this board is actually working on this input board here. So there's obviously something up with the input board on the other one. So as soon as I power it up, the relay comes on. So what I want to know is What voltage do we have here, which is the green wire in this case, on this one, and it's the blue wire on the other one, and ground? Is it a DC voltage or is it an AC voltage? Right, so I've got a multimeter set up. So I'll just measure between ground and the green wire. There we go, there should be actually 5 volts DC there. So that is the reason why the other one's not working, because there needs to be a 5 volt trigger voltage there. And I don't actually see a 5 volt regulator on this board anywhere. So I'm not sure how that's actually working, but yeah, I'd have to probe around a little bit more on the other one. However, this particular board may not pass an input signal through to here because it's not connected to the control board. The control board has a volume control on it. So I may not see a voltage here at the red wire, or a signal I should say. I'm going to try. But this amplifier has the same problem as the other one. This electrolytic capacitor here is bulging, so it's done. So there won't be much gain coming out. So what I'm going to do is, well, I'll set up the scope and an input signal and see if it passes out through to here. If it does, beauty. If not, I'll take it in the other room, connect it up to the control board, and just see if the signal comes here at the red wire. If that's the case, then I know that it's just a power amp issue, and I can always inject a signal here, so I know that this is working. Inject a signal here, get this working. I've at least fixed one. Alright, the scope's set up and my oscilloscope probe. I've jammed a little back probe here into the ground. All I've got to do is just touch the red wire with the tip of the oscilloscope probe. Oscillator's going into the input. Okay, I'll just carefully back probe the red wire. Yep, currently I'm not seeing any signal, and there shouldn't be one on the... Yeah, I don't think that is an audio signal. Well, actually, according to this, it is an audio signal, but it's 50 Hertz, which is not adjustable with my oscillator, so that's not the signal. There is no signal there, so it must need the control board hooked up in order to pass the signal. Alright, I've got everything set up in the front room. I'm going to use my signal tracer for this. I'll give it a bit more frequency though. Alright, turn the device on. There's the signal. Alright, that's all I wanted to know. So this front circuit board here is functioning fine. So all I've got to do is repair the amplifier, inject a signal into here, and test that it works. Other than that, it looks like a pretty simple job. So what I'm going to do now is I'm going to inject a signal into the power amp. I'll turn that off, and I'm going to actually see what comes out of it, just to verify what the problem is. What that basically means now is I can ignore the fact that there's going to be no signal coming through from here. So it's not relevant now at this point. I know it will do. So everything's set up. The scope is set to times 10. I believe I set it at times 10. Yeah, I think it is. Connected across the output. Input is going directly into the flux capacitor. No, going into the input connection. So I'll turn the device on, look for an output signal. Well, I saw the display jump, but I do not see anything. The scope screen is currently showing nothing. Even when I rotate my control all the way up on my oscillator, even in times 1 mode, oh, there's a very weak signal there, and it is being controlled by the oscillator. Yeah, so there's very little to no gain coming out of that. So what that means is, what's going to have to happen is the PCB out of here has to be removed, and it'll have to have that capacitor changed because that's probably the fault. What I should do is try and inject the signal. Well, I'm not going to worry about trying to inject it onto that 10 microfarad capacitor that was bad on the other one. The signal is coming through. However, it is possible that we may have an issue with our input. No, it looks like it's coming through the capacitor, so if I touch the capacitor directly with the oscillator, yeah, it's much the same story. There's hardly any gain there. Very little to no gain. Okay. Not that you could see the scope, but you're just going to have to trust me. Alright, so that capacitor has to be whipped out, which means I'm going to have to deal with more heat sink transfer compound. And that desoldered and replaced. I've got another one just over here to replace it with, another electrolytic polarized. It doesn't matter. So the things I know now is that, well, this board should pass a signal. This is for the other one, by the way. And we should have 5 volts DC over here for the relay drive control. So whatever on this board on the other one's not working, I have no clue. But at least it gives me a starting point, and I now know how this circuit works properly. So, alright, let's get to changing that capacitor and testing again. Alright, capacitor is changed. Now to test it. So I'll make sure I'm in times 10, which I am. Okay, turn it on. Well, I don't see anything on the scope. Yeah, nothing. So there's another problem here somewhere. Just want to make sure I'm getting a proper ground. Right, yeah, I am getting a ground. I just want to see if I'm getting my input signal properly. Well, I can't even see that. That's a bit better. I disconnected the input board. The input circuitry must be holding the signal down a bit, if you know what I mean. Alright, there's our signal. Nice and clean. We're in times 10 mode. Only pushing about 750 millivolts out though. The relay did engage though, so I'm wondering if we're clipping there. I'm just wondering if the main board sends out the 5 volts to this input board. I don't see how that's possible, but see, the relay is engaged. I mean, I'm connected directly at the degeneration resistors. But yeah, no, it's using the signal as it should. Interesting. Right, so if you don't know, measure it. So I'll measure between ground and the green wire. What do you know? Close to 5 volts, a little less this time, but 4.39. Okay, so that means that this main PCB is sending out a voltage, so there should be a voltage at that pin, and on the other power amplifier there isn't, so that means there is something still wrong with that module, not necessarily the input board. So that gives me a clue now and a direction for the other one to repair it correctly, which I'll do in a separate video when I'm not going to do it today. What I want to do now is I've still got an output signal, is I want to hook this up to a test speaker and the cabinet's front control panel, see if it passes a signal out through to the output. But before I do that, it would probably be a very good idea to just check what the DC offset is on the output connection, because there's nothing worse than killing the expensive sub-bass driver that's actually in the cabinet. Even though it's a Chinese made product, the cabinet is very nice and the speaker is pretty decent. So I'll turn this on. We've got nothing. So that's with the input board reconnected. Millivolts wise, 0.8 millivolts. I mean, that's bugger all DC offset. That's perfectly acceptable. so I know it's safe to hook up to a speaker. So I'm going to move to the front room now, plug in the subwoofer control board to this connector, hook up the oscillator to the input, and then, you know, hook it up to a test speaker on the floor. Alright, let's go. That apparently would be a yes. I don't know why it's clicking, it might be this driver too doing that. Alright, let me get a better driver. It's actually hooked up to the subwoofer speaker now. Sounds fine to me. I don't know if the gain is right, but I've got an output at least. Cool. Well, fairly good. So that appears to be working. Not sure if it's working properly, as I just said, whether or not there's enough gain there, but it's a start. I can give it back to the owner because it goes with the cabinet that's sitting on the floor there, and he can test it out himself if he likes and just see what he thinks. But now I know what direction I'm going in with the other one, so yeah, that'll be something that I will look at in another video, as I said. Anyway, I'm going to end this video here, and I hope you enjoyed it. At least I got one to work properly. So if you did like this video, please remember to rate, comment and subscribe, and you can always follow me on Facebook, and the links are in the description to everything as usual. Anyway guys, thanks for watching. This is the Astro 30, out.